In our previous lectures, we discussed the topic of inodes and how important they are to the file system for tracking files. That information is going to be valued in our next discussion when we start talking about file system links. There are two types of links we can create in a Linux file system. One is a hard link, and the other one is a symbolic link. Symbolic links are probably the easiest one to understand since they are basically just shortcuts. The same as if you would have in a Windows environment where you put a shortcut on the desktop. Conceptually, that's what a symbolic link is. Symbolic links are also referenced as soft links, so you may hear me use that term. Hard links are a little more difficult to digest. Hard links are used to reference data on the disk. Now understand, when you save a file to a hard drive, you're saving that data to a particular bunch of blocks or chunks of blocks on that particular hard drive. And there's an inode associated with that file. Well, we may want to reference that file by different names for different reasons. Hard links allow us to reference the data on a particular set of blocks on the disk by various names. As you'll see as we go through the demonstration, it's not that difficult to understand once you've actually created some. Some key points to understand about hard links and symbolic links are: hard links cannot span file systems. The reason hard links cannot span file systems is because of the whole concept of inodes. So let's go take a look at that real quick. I'll log in as student. I'll up arrow. And here is our df command showing us the number of inodes we have on a particular partition. So you cannot use hard links to span partitions, and the reason you can't is because each partition gets a set number of inodes, and those numbers are randomly chosen. So it's possible that on this partition I could have a inode number 1, 2, 3, 4, 5, and on this partition I could have another inode number that also is 1, 2, 3, 4, 5. Because they're on separate partitions, that's acceptable. If I was able to create hard links that spanned partitions, I could technically overwrite information on another file based on its inode. So that's why hard links are not allowed to span file partitions. You cannot create hard links for non-existing files. That makes sense. You cannot create hard links for directories. And most interestingly of all, they do not require additional storage space. That part takes a little bit of doing to understand it, but once you've actually seen them, it will make a lot more sense. Symbolic links also have some important points that we need to point out. They can reference directory systems. They can span file systems. So they can span file systems. They can represent non-existent directories, and they do take up space on the file system. We use the ln command to create hard links and symbolic links. So let's go look at both of those now. The first link we'll look at is a symbolic link. That's the easiest for most new Linux users to understand because it's really akin to a shortcut in the Windows environment. What I'll do is make a little place that we can play in. I'll move to our new created directory, and I'm going to copy a file into this directory. I'll copy etc services and use the dot. So there's our file, and if I type LLI, you can see not only the name of the file, but also its inode. Once again, pwd, see where we are. What I'm going to do now is create a link to that file inside the same directory, just so you could see the two compared. So the command to accomplish this would be ln-s, and the s is required. If you use the ln command without any switches, then it will create a hard link. So s is necessary to create a symbolic link. And I'll say services, and I'll call it my first link file. And I'll do LL here. And you can see the original file services here, and then the link. And you know it's a link for a couple of reasons. First, you see the arrow pointing to the original file. This is the link part of it. A couple of other things you'll notice that are different about symbolic links at the command line. Notice the size of the original. Let's up arrow again and type HI so we get a better picture. Notice the size of the original compared to the size of a link. Now that makes sense because it really is only a shortcut to that actual file. You can also tell it's a link by the L at the beginning of the permissions. You'll notice, and this is something that you haven't been exposed to yet, but we see pretty much what looks like all permissions have been set on the my first link file. What that's really translating to is that the system is saying follow the permissions to the original file. The permissions set on the original file are the permissions of the link. You'll also notice that they have different inode numbers. They are seen as separate files, and this one does take up a little space. What would happen in a Windows environment if you had a shortcut on the desktop pointing to a particular folder on your system and then you deleted that folder? I'm sure most of you have had that experience, and what usually happens is you'll see something like the flashlight flashing by looking for the link, and finally an error message will come up. I'm going to create that type of error here at the command line. To accomplish that, I'm going to rename the services file, and remember that's the move command. I'll rename it services.back. That's enough to disrupt the link because the original link was going to a file services without the .back. I'll press enter, clear the screen with Control L. And here is a typical example at the command line of what a broken link looks like when the color aspect has been turned on. You can see the glowing red indicating that there is a problem with that file, the original file. All I would have to do to remedy this is move the file back to its original name. And we can see that it's working fine. If I cat the my first file and tab it out, there's all the information contained in that file. Control L. What I'm going to do next is create a shortcut on the desktop to that services file. So I will remove the my first link, which removes the shortcut only and not the services file. Then I'll clear the screen and let's go ahead and create that link. Now, there is a concept I want to discuss a little bit further before we move on. It's the concept of relative versus absolute path. Vague concepts, but something that's critical to understand if you're going to be working at the command line. The relative path depends on where I am. The absolute path spells out the entire path to the particular file or directory I'm referencing. Think of it this way. If you were explaining to somebody how to get to your house, your absolute path would include what country you live in, what state you live in, what city you live in, what street you're on, the number of that, and if you're in an apartment building, maybe the apartment number. You would have to specify all that information to give the absolute path to your destination. A relative path depends on where you are. So, for instance, if you're already in the United States and you're telling somebody how to get to your house, you probably wouldn't reference the US because you're currently there. Conversely, if you were in Utah and explaining to somebody how to get to your house, you wouldn't reference the US or Utah because you're in that state. The concept of relative and absolute path on a directory structure is similar to that analogy. For instance, if I was to specify the absolute path to this file that I want to link and the desktop that I want to link it to, I would have to spell it out. Home, student, dir1, services, and I'm going to link it to home, desktop, student, desktop, link. That would be the absolute path to the service file, and that's the absolute path to the link that I'm creating that references the service file. I'll press enter, and sure enough, there you see it shows up on the desktop. If I click on the link, it opens the services file. Now the other type of path that we have, and I'll remove that link, and I will use shortcuts to describe this. As you saw, the link disappeared. The other way to reference this would be to use relative paths. Since I'm currently in /home/student-dir1 ln-s services, I'm currently there. And then I could reference the home folder with the full path. I could have done that, or another way of doing this would have been to use the tilde. That's still specifying the full path, it's just using a shortcut to do so. Press enter. The one thing I will tell you about link files and relatives paths is that sometimes the link doesn't work. I have found when creating link files throughout the file system, many times it's more to your advantage to use the absolute path to the source and the destination files. As you see over here, I've created the link, but there's a problem with it, unlike when we use the absolute paths. So shortcut links are a good way to access information quickly from different points in the file system without having to actually copy that information over. We can also use symbolic links to reference directories. What I'll do next is, from my home directory, there's a directory packet tracer, and what I'll do is I will put that on my desktop again, and I'll call it PT. Now once again, the tilde is still using the absolute path, because in this particular case /home/student is represented by the tilde. So tilde can be used to represent the absolute path. If I open up that folder, we see the contents of the PT file, which is really pointing back to the packet tracer 5. So as you see, symbolic links or soft links are really similar to shortcuts. Next, we're going to look at hard links. Sometimes describing a hard link to somebody who's never seen it before can be difficult. I'll try to use this analogy. My name is Edward Walsh Jr. That's my full name. In different places, I have people call me different names. When I lived back east, some of my friends would call me Eddie. It wasn't uncommon to be referred to by your last name only, so some people would just call me Walsh. My mother had pet names for me. You have this one person who has multiple names that they're known by. You could also think of titles that we may have. You may be Mom, or somebody's wife, somebody's girlfriend, somebody's sister. So one person can have all these different titles, or one person can have all these different names. The key is they all reference one person. One entity, lots of different names. That is kind of what a hard link is like. As you'll see, really a hard link is just a different name for the same data on the disk. So let's take a look at that. I've cleaned up our directory from the last section, so what I'm going to do is copy over the services file that we've been playing with. So copy, let's see, services, and I'll put it right here. And where we are is /home/student/dir1. First thing I'm going to do is create a shortcut symbolic link to that. So remember, that's ln-s services, and we'll call it the services soft link. I'll do an ll-i. And this is what we've seen previously. We have the original file and its size. We have the soft link, or we can refer to it as a shortcut to that, and we see that it's pointing to it. And we see some characteristics that we recognize. The inode numbers are different, right? There's an L at the beginning of the actual link itself telling us it's a link. So this is what we've seen before. Now what I'm going to do is create a hard link to that same file. And you create a hard link, you just drop the -s from it, and after that it's really the same. You reference the file and then reference the link to that file. So I'll call this hard link. Clear my screen, ll-i. Okay, immediately you're going to notice a couple of things. First of all, the hard link file that I've just created references the exact same size. The permissions are exactly the same. And most importantly, the inode number is the same inode. Remember, the system tracks the information on the drive based on inodes. The names are just for us. The system could care less what we call that information. It's tracking it by that number. So once again, think about one person has multiple names, one person may have multiple titles. That's exactly what's going on here. So we have one file, the original file, services, and then we happen to have a different name to that file. I'll create another. I'll up arrow, and this time I'm just going to call it the file. So now we have two hard links to that file. And the other thing I want you to notice, when you're creating hard links, see how this number is ticking up every time I create a link. I'll create another one, and I'll call it .4. I'll clear the screen. Every time we create a new link to the original file, or to the original inode, is really what we're doing, the link goes up Now, what was the hardest part for me to understand when I first started working with or heard about the concept of hard links, if you look at this, it looks like that this is just a copy, and that every time we create a hard link to a file, we take up more disk space. All right, we see this name over here and that size. Let's put the H option there so we can actually see in more readable format. So we see it looks like we just keep taking more disk space up every time we create a hard link, but in reality we're not, because once again all it's referencing is this number, and that number takes up this much space. So it doesn't matter how many names we give it, it's still that number taking up that much space. And we can actually see that that's true. What I'll do is edit one of the files. It doesn't matter which one I edit, because when I open one, I am opening that inode. It does not matter which name I choose to open. I'll choose to open the last one I created. And what I'll do is delete a bunch of lines in here, and then I'll save it. That was the original size. This is the original file created with that inode, and that was the size. I've chosen to edit this link, hard link, to that. And what I'm saying is that when I edit this file, all references to that are edited, because I'm really editing that inode number. And as you can see, all the files, all the references to that original file, that inode number I should say, have gone down. The short link hasn't, because it's just a shortcut to that file. It doesn't matter what size this file is, honestly. That is always the soft link, or the shortcut is always going to be a very small file, because it doesn't reference the actual information, and we can see that because it does have a different inode number. So hard links are just different names for the same information stored on the drive. As long as that original inode number exists, the information itself exists. I could remove, do an rm-f for services dot hard, and I'll just put a star there. I'll clear my screen. So we still have, right, we've removed those files, and I can delete this file here, the original file. I can delete that file, and I'll do that also, rm-f services. So the original file is gone, but that doesn't affect the data on the disk, because there's still a file referencing that inode number. The soft link is broken because it's looking for a file with that name. It does not reference the inode. It actually is referencing the name. But that's the services file, just with a different name, and we see that based on the inode. So I could, to restore that link, just rename that file, and I'll do that. And there you go. The soft link is restored. So as long as there's a file with a name, any name, that references that inode, that information is still on the drive.